Hello, this is Alaric70, and today I've got a redstone showcase slash tutorial for you, and here's what I've built. Okay, and with me today to help show you what this is, I've got Tom. So, say hi, Tom.
Hello.
So, you may be wondering what this is. It's a sort of pager, like a text messenger, um, and it sends the signals wirelessly. So as you can see, there's no wires connecting these two machines. So let me flick one of these levers. Leg spike. Okay, so you see I flicked the lever that says D, yeah,
Yes.
and I got a D on my screen. Did you get a D on your screen, Tom?
Yes, I got a D on my screen.
Okay, so now Tom is at another one of these machines about 2,000 blocks that way, which is out of render distance. And as you can
Hello.
see as well, there are also no wires running away from this thing. There'll also be a world download if you want to check this yourself. So Tom, if you could send a letter.
Send it. Oh, send a letter, yes. I was thinking letters in. Which
Or,
letter should I send? Z sounds good. Z, whatever you want to call it. Okay, that work?
hold on, leg spike.
Oh, that doesn't look like a Z to me.
It's an E.
It's on its side for me. I think this display may be messed
Well,
up.
okay, so that's kind of interesting because that's a point that I noticed before, is there's like a 1 in 50 chance of it sending the wrong letter. Just because
Huh.
that leg spike, sometimes it doesn't get it
Oh,
right.
I
So,
see.
why don't you try again, Tom?
Okay. There we go.
Yep, Z. Okay,
Oh, I think I have a faulty pixel here, but that's it.
a faulty pixel.
Yeah,
That's odd.
well, it was wrong in the D and the Z, so I think it's. Let me trace this back.
Ah.
Anyway,
Okay, well,
continue your
if
demo.
there's a broken wire, I will fix that in the world description. Uh, so yeah, and as you can see, it's up to 6 letters will be saved at a time on each screen, and it's got the characters. It's got all the way from blank 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and it's got A through Z, plus we've also got some special characters such as the period, the exclamation point, the question mark, the forward slash, the ampersand, the comma, the apostrophe, and the dash. Uh,
And caps.
hmm?
You have both caps and lowercase.
No.
Don't you? What? But oh no, never mind.
Yeah.
It's you being dumb. Or you
Um,
putting things up
yeah.
science.
Well, it can be extended to have caps and lowercase, but that
Yeah,
would double the size of the decoders. Um,
that would be fun.
yes.
Actually, I
Okay.
wonder if you could even fit that in render. Yeah, you probably could.
Yep. Okay, so the next part of the video, that was the demonstration. The next part of the video is going to be explanation. So I'm going to talk about the pieces and tell you what they do. I'm going to start from the screen and work my way backwards, I guess. So the screen, let's see, has a lot of wires running up to it. And all these wires are coming from a bunch of D flip-flops or data flops, um, which will store the input given to them on a clock input, which is down here, and will not um, be toggled to however the input might change until the clock um, pulse comes along again. So feeding the screen and D flip-flops is this massive sort of, I don't know, it's like a font file because it saves each one of these lines is a different character, and the torches on them indicate what pixel is lit up for each character. So as you can see, they're labeled so you can look at them. And those, there's two of them stacked on top of each other just to save space so it doesn't extend off in the distance too far, because then it has a chance of getting out of render distance. And those are fed by a binary decoder, which is this row here. There's also two of those just stacked on top of each other to save space. And those get their signal from, I don't know, the quantum entanglement receiver. um, and this is based off of a sort of, I'm not sure if it's a glitch or a feature in Minecraft, but all the hitboxes on all the glass panes and iron bars in the entire world behave as if their hitbox is the same.
They are sympathetic.
Yes, indeed. Quantum entangled sounds more epic.
True.
But what is causing them to change shape and allow the boats to fall through is this machine over here, um, which, as you can see, has pistons to push up different blocks, changing the shape, and the arrows, which are fired by this piston, and then, no, sorry, fired by this dispenser, hit this piston, sorry, this block that this piston is holding, and then hit on or near the fence gate, and this is what causes the hitbox check on this one. So when this one's hitbox is checked, it updates all the hitboxes all the time. And it does that with both the glass panes and the iron bars. So you get 8 channels, because each glass pane or iron bar has 4 sides. Um, and this machine also, once every minute, refreshes the arrows, because arrows have a 1-minute despawn timer. It also has built-in logic for having multiple of the machines, because since it can only listen to one glass pane or iron bar at a time, when somebody else sends a letter, you have to refresh your arrows as well, because otherwise it'll be still listening to their glass pane and iron bar. And that's this, so I'm using one of the iron bar directions as a sending indicator, and that fires the clock line that I talked about before. And this takes its input from a big encoder, which is where we started with all the levers for the different characters. Okay, so we'll see you in the next part of the video where we will give sort of tutorial type things on building decoders and encoders and the D flip-flops, and more on the quantum entanglement. Okay,
Yay. Quantum entanglement.
see you in a sec. Okay, so welcome back. We've got a couple demonstrations set up here to show you, and Tom's still here. So yeah, we're gonna start with the encoder and the decoder. So the encoder takes like 1, 2, 3 and turns it into binary 1, 2, 3. So if you don't know what binary is, it's a sort of counting system that computers use where each decimal can only be 0 or 1.
It's
So
base 2 counting, so we count in
yeah,
the
base
base
2
10
counting.
system. Base 2 is binary. And you can
Yes,
represent everything you can represent in base 10, in base 2, and likewise.
yes. So as you can see, it's on 0 right now, and that goes over to the decoder, and this is the 0 light. if I flick the 1 lever, so binary for 1 is still just 1, it goes over here and the 1 light is lit up. And if I light the 2, and binary for 2 is 1, 0, okay, goes over here and the 2 light is lit up. And then this is the 3 light, and 3 in binary is 1, 1, and 3 is as high as you can count with only 2 bits. And then the decoder, what it does is, let's see. So it's got inversions so that since both of these are off, both of these torches are depowered, allowing this light to light up. But with the number 1 thing, only this one is double inverted and this one is single inverted. So that this one is off and this one is off, allowing this torch to turn on. On 2, it's the other way around. This one's single inverted and this one's double inverted, so they're both off at the top, allowing this one to turn on. And on 3, they're both single inverted, so they are both off at the top, allowing this one to turn on. So the version of decoder I used over there is actually different, because if you look at this one, every 2 things you have, or every 2 outputs, you have to have a repeater. So if you wanted to extend this, you'd have to put another repeater here. So every 2 things you have a tick of delay, which makes, if you have a really long one, it makes the end one really slow. So this is actually the design I used. As you can see, the lines go all the way from one end to the other, and it just it sends the power through an extra invert up to here, and then this top part is exactly the same as the very top part of this. Um, so basically each output is 1 tick slower, so it takes an extra tick for the output to, after the input changes, it takes an extra tick from that one for the output to change, but you don't need all the extra repeaters in between each one. So if you have a really long one, the end one on that will be quicker than the end one on this one of decoders of similar length. And you can see it works just the same, 0 light, oh, 0 light, 1 light, 2 light, and 3 light. Okay. And that should basically cover that. So then the next thing, which I showed you behind the screens, are the data flip-flops, or D flip-flops. And here's one extracted right here. So this is the input, and as you can see, flicking it does not change the output immediately. But if I have the input off and the output is currently on, and I send a clock pulse, you'll see the output turns off as well. And then if I change the input again, it won't unless I send another clock pulse. And if the clock is left on, it'll change whenever you flick this lever. And how that works is there's a RS NOR gate right here, which basically this torch being on keeps this torch off, and if this torch is on, it powers the block with this torch. But this extra bit is for the clock signal. It interrupts both sides of the input, as it were, to the RS NOR, so that the RS NOR can only toggle when the clock input's on. And as you can see, you can just use, like, freeze the video here. If you want to know how to build one, just copy it block by block, I guess. 1 second, let me set the time. And then we can look at how the quantum entanglement sort of happens. So let me get a bow out. So right now, there are no hitbox checks being performed on these glass panes. But if I shoot this one with an arrow, that causes a hitbox check. So then if we, oh, 1 second, I'll have to, okay. So if we cause a hitbox update on this one, and then move this one, you'll notice the boat was able to fall through it. And then over there, what I have is a pressure plate right here, so that when the boat's down, it powers it. But when the boat is up, it does not power it. Okay, and you can do that for all 4 directions. So 1 second, I'll probably skip this part of the. Okay, back. So as you can see, if I shoot this one and then move these, that boat is allowed to fall through. But if I remove the arrow from that one and put it in this one, where the hitbox is shaped differently, and then move these,
Spooky action.
yep, this one is now allowed to fall through, okay? But those two still aren't. Yeah, okay, and then if I remove that arrow and shoot at this one, oop, and then move these, you see that that one is now allowed to fall through, okay? So same thing with this one. And if you want them all to be up, you can either have one with blocks around it or one without blocks around it because it has the same hitbox. Oops.
Actually, I may have the directions wrong here, but close enough.
Oh. So in the actual receivers, there's a clock that's designed to give a special pulse, um, which will. Okay, well, anyway, what it basically does is,
Spazzy.
yeah, it spazzes the piston, but it pushes it up, which you see for a second, pushes the boat up, and then in that time withdraws it and then pushes up again so that it's then sitting on top of the glass pane again. It's just a really hard pulse to create by hand. And you can also send multiple sides at once. So like if I have these two unconnected and send that and then move these, you'll see that those two sides allow the boats to fall. So it activates just those two. And you can do 3 as well. So you see the side with the block, the boat remains up, but the sides without, the boats are allowed to fall and will rest on the pressure plates. So yeah, but I didn't discover this particular mechanic. I'm gonna have to link you to a video. I forgot the person's name who discovered it. And then I guess I'll give you a look at the clock. So this is one of them. So it's just I think it's a 5-tick clock. Okay. So yeah, I guess that's about it.
It looks to be
So
5-tick.
yeah, I'm pretty sure it's 5-tick. So thank you very much for watching. This is Alaric70 and
Tom, I guess. Yeah.
I don't know, signing out or something.